Okay, so get this. Today we are diving into a world where you can access the brain for treatment, but it doesn't require, like, opening the skull.
Wow.
Yeah, forget scalpels, forget surgery.
Right.
We're talking about a revolutionary new approach that's minimally invasive.
I know. It is remarkable.
And maybe even, I don't know, a little bit sci-fi.
A little bit.
Yeah.
Yeah, this deep dive is going to explore this groundbreaking new technology called the Endocisternal Interface, or ECI.
Okay.
And we're going to use some pretty interesting sources for this. We've got research articles, a LinkedIn post analysis, even an abstract from a study published in Nature Biomedical Engineering.
And the crazy thing is,
Yeah.
imagine accessing the brain, like, for treatment through a small puncture in the lower back.
Yeah,
You heard that right?
it's pretty wild.
So, we'll break down all the details, but first, let's just figure out what this ECI actually is.
Okay, so the ECI is all about using the body's, natural pathways. So instead of going through the skull, it uses the cerebrospinal fluid, which is also called the CSF, and that surrounds the brain and spinal cord.
So it's like using a pre-existing network to reach the brain.
Exactly.
Sort of like, like a subway system for medical devices.
Yeah,
Yeah.
that's a great analogy.
Yeah.
So the ECI involves this minimally invasive procedure called a lumbar puncture,
Okay.
and that's done in the lower back.
Uh-huh.
And from there, they can basically navigate a flexible catheter through the CSF to access different areas of the brain and spinal cord.
Okay, so this catheter isn't just, like sightseeing, right? It's
Yeah.
got some pretty serious tools on board, right?
Absolutely, yeah.
Yeah.
So the catheter has tiny electrodes and a wireless system,
Okay.
and it's all powered by magnetoelectric bioelectronics.
Wow.
And this allows it to both record electrical signals from the brain and spinal cord, but also stimulate specific areas.
Oh, wow. So it's like a two-way communication system.
Exactly.
So it's listening in on brain activity and sending instructions.
Amazing.
I mean, why haven't we always used this approach?
I know, right?
What's wrong with the old way?
Well, I mean, traditional brain surgery often involves a craniotomy, which is literally opening the skull.
Yeah.
And it's a really major procedure.
Oh, yeah.
It has risks like infection and bleeding and potential damage to the surrounding tissue.
That makes sense.
Yeah, and even less invasive methods, like the ones that go through blood vessels, they also have some limitations.
Okay, so the ECI just like bypasses all that.
Yeah, pretty much.
So what are the advantages here?
Well, I mean, this is a game changer in a lot of ways.
Mm-hmm.
It gives broader access to neural targets, and it can reach both the brain and spinal cord at the same time.
Oh, wow.
It also has a much lower risk of complications,
Right.
and it doesn't require any antithrombotic medication.
Okay.
But probably most importantly, it can be repositioned, like the catheter can be repositioned, and even completely removed after use, which you can't really do with, other neural interfaces.
So hold on. You're saying this thing's removable.
Yeah,
I mean, that's a huge benefit, right? Especially when you think about, like, long-term treatment.
absolutely.
It's not even just about avoiding the risks. It's about, like, opening up new ways to deal with neurological conditions, right?
Yeah, I mean, precisely.
Yeah.
This has the potential to really change how we treat conditions that were once considered either untreatable or extremely difficult to manage.
Yeah, I bet our listeners, like, sitting there, thinking about all the possibilities.
Right.
I mean, we're talking about real hope for people who are, struggling with all these different neurological disorders.
Absolutely.
But before we, get ahead of ourselves, we have to address the big question.
Yeah.
They actually tested this ECI in,
Yeah.
living beings, right?
Yeah, they did, and that's where things get really exciting.
Okay.
The research team didn't just come up with this idea. They actually put it to the test, but they did it, very carefully and methodically.
So how did they go about that? Like, what did the testing involve?
Well, they started by using MRI scans
Okay.
to map out the endocisternal space in humans.
Uh-huh.
So they were basically creating this detailed roadmap of all the CSF pathways.
So it's like a GPS for the brain's, fluid highways?
Exactly.
That's pretty wild.
Yeah.
Okay, so then what?
So then they moved on to experiments with sheep,
Okay,
because their cerebrospinal fluid system is really similar to humans in size and structure.
makes sense.
So,
So what did they do with the sheep?
so they implanted the ECI devices, and then they ran a bunch of different tests, and they were able to record electrophysiological signals. So basically, they were listening to the electrical activity in the sheep's brains and spinal cords.
So they could actually hear the brain talking, so to speak.
Yeah, pretty much.
Wow, okay, so what about sending instructions? Like, did that work?
Yeah, they were able to successfully stimulate specific areas of the brain and spinal cord and get the responses they were looking for.
Whoa, all that, and it's all through a little puncture in the lower back?
Yeah.
No brain surgery.
Nope.
That's amazing.
Yeah, and here's the really amazing part. The ECI worked for up to 30 days,
Wow.
and there was very minimal damage to the surrounding tissue.
Well, wait, 30 days?
Yeah,
I mean, that's not just a quick fix, you know? That sounds like it could be a long-term treatment, right?
exactly, and that's what's so significant
Yeah.
because it means we could potentially have continuous monitoring and treatment for all sorts of neurological conditions.
Well, we've got this minimally invasive device that
Yeah.
can record brain activity and it can stimulate it.
Right.
And it's been tested
It's been tested.
in living beings.
Yeah.
And it can be used long term. This is starting to sound less like science fiction and more like, the future of medicine, honestly.
I know, it really does. The possibilities are vast. I mean, the implications for treating all these neurological disorders are just huge.
Okay, so let's talk about the future then.
Right.
What are some of the ways we could apply this ECI technology? What could this mean for people who are suffering with these neurological disorders?
Well, the research highlighted a few key areas,
Mm.
like stroke rehabilitation, epilepsy monitoring and treatments,
Okay.
and spinal cord stimulation for pain management. But those are just the beginning, really.
What else? Like, what else is out there? Could this be used for neurodegenerative diseases? Like Parkinson's,
Yeah.
Alzheimer's?
Yeah, imagine what we could do with those conditions.
Yeah.
If we could use the ECI to monitor how the disease is progressing, maybe deliver therapies right where they're needed, or even stimulate specific parts of the brain to make up for lost function.
Yeah.
I mean, it could be life-changing for millions of people.
This is crazy. What about mental health conditions? Like, could we use this to treat things like depression or anxiety?
That's an area where there's a lot of research going on,
Mm-hmm.
but we need to be cautious,
Yeah.
The idea of using targeted brain stimulation to change someone's mood or behavior
Yeah.
is really promising. But it brings up a lot of questions about, is it ethical?
Yeah.
And what are the potential implications of doing that?
Right. Just because we have the technology doesn't mean we should just go wild with it.
Exactly.
Yeah, there's a lot at stake.
Absolutely, yeah. We need to be really careful about unintended consequences and make sure that, anything we do with this technology
Mm-hmm.
prioritizes the well-being of the patients and lets them make their own choices.
Absolutely. Okay. But before we get too deep into that, let's switch gears a bit and see how this cutting edge science is already capturing people's imaginations.
Okay.
We've got some really cool data from your LinkedIn profile that shows this. Yeah, the LinkedIn analytics, it's a great example of how this research is already generating so much buzz. You shared some information about the ECI on your profile,
Right.
and the response was incredible.
It was.
Tons of views, lots of engagement.
Mhm.
People are really fascinated by this.
Yeah, I think it just goes to show you the power of, making these complex scientific topics accessible and also engaging.
Yeah.
When people can understand the potential impact, they get curious, and then that can lead to more support for this kind of research.
It's like we're watching the birth of something really revolutionary.
Yeah.
And it's not just happening in labs and research journals. It's reaching everyone.
Absolutely.
But let's bring it back to our listener.
Okay.
We've explored the science, the potential applications, and we've touched on the ethical considerations. Now, I want to know what you think.
Right. This is where it gets personal.
Exactly. I mean, we've given you a ton of information, but what does it all mean for you? How does this cutting-edge research connect to your life, to your health, your future?
Yeah, think about it. I mean, if this ECI technology becomes, widely available, how do you think it'll change how we approach neurological health and treatment? Will it be a good thing?
Mm.
Will it help us live longer, healthier, more fulfilling lives? Or will it create new problems and ethical dilemmas that we'll have to grapple with?
I mean, those are some big questions.
Yeah.
And honestly, I don't think there are any easy answers.
Right.
But they're definitely worth asking.
Absolutely.
I mean, the future of neurotechnology, it's not something that just happens to us, It's
Right.
something we create with our choices and values and actions.
Yeah, that's a good point. This isn't just about facts and figures.
Right.
It's about people
Mm.
and how we use this knowledge to change the world.
Yeah, and one thing that really sticks out to me is, just how fast this field is moving.
It's incredible.
Like, we're talking about a technology that was basically science fiction, like, a few years ago.
I know the pace of innovation is just mind-blowing.
Yeah, and the ECI is a perfect example of how quickly we can go from, like, a breakthrough in the lab to something that could actually change people's lives.
Absolutely.
So, okay, let's think about our listener for a second. What does this mean for you? Imagine a world where conditions like, Parkinson's, Alzheimer's, even chronic pain could be treated with a procedure like the ECI.
It's amazing to think about, right? I mean, think about stroke rehabilitation.
Yeah.
Instead of months and months of really difficult physical therapy,
Mm-hmm.
imagine something that could help rewire the neural pathways and make recovery so much faster.
Yeah, it's like hitting the reset button on the brain.
Yeah, kind of.
And for epilepsy, the ECI could, I don't know, could it monitor brain activity and, like, actually step in before a seizure even happens?
Exactly, yeah. We're talking about going from reactive care to actually being proactive and preventing things, which would, improve quality of life so much for people with these conditions.
Yeah, like an early warning system for your brain.
Yeah, exactly.
But let's not get too excited. I mean, this is still early. There's a lot more research to do.
Right, of course.
What are some of the challenges that researchers are still working on?
Well, one of the main ones is just improving the precision and targeting of the ECI.
Okay.
And they've come so far.
Yeah.
But being able to stimulate or record from, really specific tiny groups of neurons, that's still a challenge.
So it's kind of like trying to hit a bullseye on a moving target.
Yeah, exactly.
Okay.
And, the brain's an incredibly complex organ. It's always changing, so that level of precision is really hard to achieve.
Right, right.
But researchers are getting closer all the time.
That's great. And what about how long the device lasts? We talked about it being functional for 30 days in those sheep studies.
Right.
But what about, like, for people long term?
Yeah, that's another really important area of research.
Okay.
They have to make sure that the device is still biocompatible after a long time.
Uh-huh.
And that there aren't any side effects from, stimulating or recording for a long time.
Yeah, it's got to be safe and effective, especially down the line.
Yeah, for sure. You don't want something in your body that's going to cause problems later.
Exactly.
And beyond those technical challenges, there are, all the ethical things to consider as well.
Okay, yeah, let's talk about that. I know you think that's really important. What are some of the,
Kind of, yeah.
I mean, who has access to that? How are they using it? These are questions we have to ask.
Absolutely. And it's not just about privacy. It's about autonomy, too.
Okay.
As this technology gets more advanced, we need to think about, the potential for coercion or manipulation. What if someone's brain activity could be monitored or even influenced against their will?
That's, yeah, that's a little creepy.
Yeah.
It sounds like something out of a sci-fi movie.
Right.
But, I mean, we have to acknowledge those risks.
Oh, absolutely.
So that we can, figure out ways to prevent them.
Yeah, it's really important to be having these conversations about the ethics now before it's too late.
Right.
Before this technology is everywhere. We need clear guidelines and rules to make sure it's developed and used responsibly.
Yeah, it's about finding that balance.
Yeah.
Between innovation and being responsible.
Exactly.
We want the benefits,
right,
but we don't want to cross any ethical lines.
For sure. And to do that, we need to keep talking about it, thinking about it. And scientists, ethicists, policymakers, and the public all need to work together.
And that's what we're trying to do here.
Exactly.
Start the conversation, get people thinking, and hopefully, contribute to a future where we use neurotechnology ethically to make things better for everyone.
I couldn't agree more.
But before we get to, too philosophical, why don't we just go back to something more concrete? The research, those LinkedIn analytics we mentioned earlier, they're pretty fascinating. They give us a glimpse of how, this cutting-edge science is already capturing the imagination.
Yeah, definitely.
I mean, the analytics show that there's a ton of interest and engagement.
Right.
So people obviously want to learn more about all this.
Yeah, for sure.
It shows that people want information, and they're not afraid of, these complex scientific topics.
It's encouraging to see.
Yeah.
It seems like people are becoming more aware of the potential of neurotechnology, and they're willing to, think about the complicated parts and the ethical questions that come with it.
Yeah, but it's not just about being aware, it's
Uh,
about understanding.
yeah,
And that's where good science communication comes in.
absolutely.
I mean, we need to bridge that gap between the lab and the public
For sure.
and make, complex research accessible and interesting for everyone.
Yeah, we have to get rid of all the jargon, highlight the good stuff,
Yeah.
and talk about the concerns in a way that everyone can understand.
Yeah, because at the end of the day, the future of neurotechnology is up to all of us.
It really is.
Not just scientists and engineers, but policymakers, ethicists, everyday people.
Yeah, everyone.
So as we wrap up this deep dive into the world of the ECI and minimally invasive neural interfaces, we want to leave you with one final thought.
A thought to really ponder.
A thought that maybe you can talk about with, a friend, a family member, even a stranger on the street.
Mm-hmm.
We've talked about, all the amazing things this technology could do. Treating things we thought were untreatable, opening up new possibilities for health.
Mm-hmm.
But, let's be real. This ECI technology, it brings up some big questions.
Yeah.
Questions about privacy, about our choices, even what it means to be human in a world where, we can mess with our own brains.
It's like opening Pandora's box.
Right.
Yeah, we're going into uncharted territory.
Yeah.
It's exciting, scary at the same time.
Exactly, and that's why we need to be having these conversations now
Right.
while it's all still developing. We have to be proactive.
Uh-huh.
We need to think about the challenges before they happen
Yeah.
and set up ethical guidelines to make sure it's used responsibly for good.
I think you hit the nail on the head. Responsible development, responsible use.
Right.
We can't just jump into every new technology without thinking about what could go wrong.
It's like, with great power comes great responsibility.
Exactly.
And this ECI technology, I mean, it could be really powerful for
Yeah.
good or bad. It depends on us.
It does.
So what can we do? How do we make sure it's used ethically to help people?
Well, I think education is a big part of it.
Mm-hmm.
We need people to understand, what this technology can do, the good and the bad.
Right.
We need to be open and honest about the ethics.
Yeah.
We need to explain the science in a way that makes sense so people can make their own choices.
I like that, explaining the science clearly, because
Right.
this stuff can be, complicated.
It can.
But it doesn't have to be scary. The more we understand it,
Mm-hmm.
the better decisions we can make.
Right. And those decisions matter.
Yeah.
They'll affect not just us, but everyone.
I mean, think about it. If the ECI becomes as common as, smartphones are now,
Wow.
it could change everything.
It really could.
How we interact with the world, with each other, even ourselves.
It could blur the lines between, what's biological and what's technological
Yeah.
in ways we can't even imagine yet.
It's kind of mind-blowing.
It is.
But that's also what makes it so interesting, right?
Yeah, for sure.
We're seeing human ingenuity at work,
Absolutely.
and we're all part of it.
We are. And this is just the beginning.
So where do we go from here? What's next?
That's the exciting part. We get to decide
Yeah.
through research, innovation, debating the ethics, making informed decisions.
Yeah.
That's how we'll shape the future of neurotechnology.
It's a team effort, and we all have a part to play.
Yeah.
So stay curious, keep asking questions, and talk about it.
Right.
The choices we make now will decide what this, brave new world of neurotechnology will look like.
And who knows what amazing things are waiting for us.
I'm really optimistic, This ECI, it's just the tip of the iceberg.
Yeah,
I think we'll be talking about this a lot more in the future.
definitely. This is just the start of something incredible for neuroscience and human potential.
So to our listener, we'll leave you with this. Stay informed, stay engaged, and stay curious.
Yeah.
The future's up to us.
And until next time, keep exploring.
See, yeah.